Thank you for joining us today for one of the very exciting of our application webinar series here at 3D Systems on getting the clearest parts possible from your 3D printer. Quickly, I want to introduce today's speakers. We have John Paul Velasco, who is an application development specialist with 3D Systems. And John Paul is going to be taking us through the technical details of how to actually go about clear coating parts and all of the steps necessary to get really high quality, very clear parts from your 3D printer. And myself, Tom Sharon, I am the VP of Product Marketing at 3D Systems. I'll be emceeing and talking a little bit about our 3D printers that print out the clearest parts on the market. Very brief introduction to 3D Systems for those of you that don't know us. We are a publicly held company based in Rock Hill, South Carolina. We are both the originator of 3D printing and the shaper of future 3D solutions. And we really pride ourselves on making the printers, software, services, all aspects of 3D printing more accessible, simple, productive, and gratifying so that you can transform your ideas into tangible outcomes. For those of you not familiar with 3D Systems, you may not know that we make a wide variety of 3D printers, by far the largest portfolio of print technologies on the market. And we have printers that range from under $1,000, like the Cube Home 3D printer, all the way up to systems in excess of $1 million that are large production systems that create a lot of high quality parts very quickly in metal, in very tough plastics, and a variety of different materials. And of course, a variety of systems in between for prototyping, healthcare, concept modeling, so on and so forth. And as we think about 3D printing applications, we can group them into 5 primary categories. We have communication models or concept models, and these are used to, as it says, communicate ideas, right? And so we know the power of being able to hold something in your hand to really understand, especially complex geometries. It's far better to hold something in your hand than to look at it on a computer screen or on a printout. Then we have functional prototypes, which is really all about validating ideas and validating engineering concepts. And when it comes to functional prototypes, you want parts that approximate the end-use part very closely in its properties so that you can test it properly. And we have a variety of materials and print technologies that allow you to do that. Of course, a lot of functional prototypes are clear parts. So many of you are probably looking to make clear parts for your prototyping process. You can also use 3D printing to do rapid tooling, which is great for a pre-production or even a low-run production environment. You can skip tooling and go straight to end-use parts with 3D printers, metal printers and plastic printers. We have systems that make parts that are strong and durable enough for long-term use, and in fact, in many ways, are superior to parts produced via other manufacturing methods. And last but not least, we have mass customization, and often this is a healthcare type application where we're making millions of individual parts, and some industries in healthcare, such as dentistry and hearing aids, have been completely changed by 3D printing over the past few years. And we're seeing a lot more healthcare applications, including implants and surgical guides and surgery planning, being revolutionized by the availability of 3D printing. Now with that, I'm going to hand it over to John Paul so that he can take you through the agenda and what he's going to cover from a technical standpoint today.
Hey, can you hear me, Tom?
Yes, I can. Thank you, John Paul.
Oh, perfect. Okay, so how's everyone doing today? Again, I'm John Paul. So here's what we're going to cover today. We're going to talk about what is clear coating. We're going to talk about standard methods that are currently being used to get clear parts. We're going to talk about when to use a 3D printer as opposed to a standard method. Solutions for you, so what are the different printers that we have? 3D printers and the whole process that it goes through to get these clear parts. And then at the very end, we're going to talk about some real-world examples in industries that use and need these type of products. So first off, what is clear coating? Simply put, it's a process to improve the surface finish and transparency of a clear plastic part. It's the same process that a lot of people use for clear coating or to get other clear parts with traditional methods. So if you guys have ever had to refinish a headlight on a car, it's a very similar process, and that headlight was not 3D printed. So this process is not like it's revolutionary new. It's an existing process for clear parts already. Also here I want to draw your attention to the two pictures at the bottom. This is before the clear coating process in the first picture, and then after the clear coating process in the second picture. It's the same part, it's just the process that goes through improves the transparency. So why are some parts clear and some parts more opaque? It really has to come down to the surface finish. Right. So something with a coarse surface finish, it doesn't transmit the light as well, and as a result, it gives a more opaque appearance. If something's smooth and there's very few defects, and again, assuming the material is clear, it will be transparent. So how are clear parts traditionally made? So the quick process here. So for the standard, you have to go through a tooling process. So this would be like injection molding, blow molding, or vacuum forming. And so all three of these processes need a mold or tooling to make these parts. And then more than just like a standard injection molding mold, you actually have to polish these tools, right? Any artifacts from the machining process, any defects will actually go through and show on the plastic part when it's being molded. So you have to polish this tool even more than you would just with a normal opaque plastic. And then obviously the next step is to create the part with the process. And then some industries or some applications actually require additional finishing after the part's been molded. And so they'll go through the exact same process we're going to teach you right now, where they polish it up to remove any surface defects. So the downsides to this is it costs thousands of dollars to make the tooling. Anyone who's experienced with any of these processes, it's expensive to make the tooling, it's expensive to go through all the polishing of the tool to get it. And then really it takes a minimum of 2 weeks. So Tom briefly touched on this already, but the two areas we found that this application works best are functional prototypes and short-run production. So now we're going to talk about the solutions we have, so the printers and the processes in place. So as you know, 3D Systems has a very wide variety of 3D printers. So we have 7 different print technologies. These are the 3 we recommend. We've tested this process on all 3 of them. So we have micro SLA, which is microstereolithography, MJP, which is multi-jet printing, and then SLA, which is stereolithography again. So when you're selecting which print technology to use, there's a couple factors you need to keep in mind. The first and foremost for getting clear parts is surface quality. And the second would be maximum part size. How big are the parts you're going to be making? The next one is additional uses of the printer. So are you only going to be making clear parts? Are you making clear parts and other parts? Are some of them going to be clear coated, some of them not? So these are the things you have to keep in mind. And then volume of anticipated 3D printing. How many parts are you going to be making on a weekly basis, on a monthly basis? And then finally, cost of printer and per part cost. I also want to draw your attention to the picture here on the right. So this is the part, so in order, it's the part off the machine, and then it's the part sanded, and then it's the part actually clear coated or painted. And you can see how drastically the clear coating process improves. And we'll go into steps and show you each of those images separately. So here's the printers that go with each print technology. So with micro SLA, we have the Project 1200, and then with MJP we have the Project 5500X, and then with the SLA you have the Project 6000 and 7000, and the Pro X 800 and 950. So here's kind of a quick table breaking down of how to select each one. So speed, by far the fastest, is micro SLA. It also has the smallest build area, with 1.69 by 1.06 by 5.9 inches. Whereas SLA, it's faster, but it has the highest machine cost, but it can do the largest area. You can do things that are 59 by 30 by 22 inches. So it makes the largest parts by far. And then here's the cost per part and cost per machine. Surface quality, all these machines and materials are capable of creating the clearest part out there on the industry, or out there on the market. But what you have to be aware of is that with MJP, it just has to go through a little additional finishing. You can get the same level of clarity, but it just has to go through the same process, but it's a little longer to sand and remove and improve the surface finish. So now we're going to talk about the simple 3D printed process. So first we're going to talk about the materials that are going to be needed. So we're going to quickly go through these. So the hobby knife with curved and straight blades, sandpaper of different grits, and what grits are dependent on which process you're going to do. And now the paints. So if you're going to do a basic clear coat, you can use an aerosol clear coat. We like the Rust-Oleum 2X Ultra Cover. We found it works well. It's very good at sticking to and covering the parts and getting everywhere, but not leaving runs as well. And then for advanced, you have to use a painting booth with a spray gun. And then we recommend using an automotive clear coat, and we prefer to use high solids. Excuse me one second. Can you guys hear me now? Okay. Perfect. So again, an aerosol clear coat for basic, and we recommend the Rust-Oleum 2X Ultra Cover. And then for advanced, we recommend an automotive high solids clear coat. And so an automotive clear coat comes in 3 parts. It comes as the clear coat itself, the hardener, and the reducer. And then there's an optional material you can add called fish eye remover. And we'll explain when to use that, but these are the 3 base components and the optional components that go into the clear coat. So the first step of this process is to print the parts. So again, here's the print technologies, and the materials are at the bottom of what I want to draw your attention to. So there's the VisiJet FTX Clear for the Project 1200. There's the VisiJet CR-CL for the Project 5500X. So I know some of you guys are wondering where the 3500 is. The crystal material can be clear coated in the same process, but just by the nature of that material, it's not as clear as these other materials that we're recommending. It can be done, and it's the same process, but just be aware that you won't get the maximum level of clarity as you would with these other materials. And then you have the Project 6000, 7000, and the Project 800, 950. And those materials are the VisiJet SL Clear and the Acura Clearview, respectively. So then the second step that you guys need to do is determine what level of clarity is actually needed for your process or application. So the first one is option 1, which is as printed. So this doesn't require any painting or sanding. And if you choose this option, then you don't need to continue on. This is all you need. We tried putting the parts next to this image on the back of the eye chart, just so you can see. So you can see you kind of can make out the red line, a little bit of the green. So you can see the shapes in image or a little bit behind them with this type of finishing, but you can't really make out all the tiny little details of the layers behind it. But for some applications, this is all they need. So particularly form fit, if you don't really need to see everything behind it, you just need to see where it's touching, this is usually adequate. And then the next option is basic clear. So with basic clear, you have to sand the parts up to 120 grit, and we'll tell you the exact process to go through. And then you can exfoliate it with an aerosol clear coat. And you can see here on the picture on the right, it looks much better. You can see a lot of the letters. You can't see the letters exactly on the lower lines, but you can see the shapes and generally get most of the detail behind it. And then option 3 is the advanced clear coat. And so you can see here from the image, you can see all the letters. You can even make out the letters on the very bottom line. And this requires actually less sanding than basic. You only have to go to 320 grit. And then you have to spray with the high solids automotive clear coat. One quick note on high solids. So the difference between high solids and low solids paints is there's more paint to actual other components, so other like the thinner. And so when it dries, the paint doesn't shrink as much, and so you get a better, more even coat of paint. So we recommend high solids. So then the next step is sanding the parts. So you can see from the two pictures on the side, before sanding you can barely make out anything. After sanding you can make out the red and green lines. You can see a little bit of the shapes behind it. A couple quick best practices to follow is you always want to remove the sanding lines before progressing to the next grit. So what this means is, say you're going from 150 to 220 to 320. You don't want to go to 320 before you get rid of the lines from 150. Basically is as you go finer in sandpaper, so as we know, the higher number for grit, actually the smoother the sandpaper is. And so as you get smoother with the sandpaper, it doesn't have the ability to get rid of the sanding lines from sandpaper before it. So you have to make sure you remove all the sanding line with the next step, because if you go too quickly, the scratches will be there, the sanding lines will be there, and you're going to have to go back up to get the truly clear part. Another thing we recommend is wet sanding with water. So you have to get sandpaper that's wet or dry. And what it does is it helps you do a more even sand. You're less likely to gouge, or it just gives a better consistent sanding. And if you do wet sand, the one thing is you have to make sure the parts are clean and dry before painting. Make sure there's no dust or particles. And so usually just wash it off either with water or IPA, some people use. And the next thing is a hobby knife. So the hobby knife we were talking about at the beginning, it can be used to scrape instead of sand difficult to reach spots. So like if there's like tiny little nooks and crannies that you can't really get sandpaper in there, or you're afraid the sandpaper will damage, you can use a hobby knife just to smooth it out. It's also good for preserving like sharp edges. If you don't want to put sandpaper on there because you'll lose the sharp edge, you can just take a hobby knife and run it across and remove any roughness there. So the sanding process for basic is you start with 180 grit, then you go to 240, and then when the sanding lines are gone from 180, then you go to 400, and then you go to 800, and you go to 1200. Sorry, it's a little, I couldn't really think of a great way of expressing this, but basically you have to progress from rough sandpaper to smooth sandpaper. and you can't go too quickly, otherwise you won't get rid of the sanding lines from the previous sandpaper. And then at the very end, you want to remove the dust, either by wiping or blowing off parts. For advanced, you want to sand, it's actually less sanding, and the reason why is the clear coat that you spray with the automotive paint, it actually is thinner, it's more running, and so we'll go through and fill in all those little cracks and crevices. So there's no point in sanding more than that because those sanding lines are all going to get filled in with the paint. And so you start with 150, then you go to 220, then you go to 320, again removing the sanding lines from the previous grade. And again, before painting, you want to remove dust. So now comes the fun part of spraying. So with basic, you just spray with the aerosol clear coat. With this one, you can put on a couple coats if you like. So try not to overload the part with the aerosol can. And with advanced, you spray with high solids automotive clear coat. And now you can see the two different ones between each other. You can see how they compare. And so some best practices for you guys who are going to be doing this. Obviously, the first one is spray in an area free of dust, right? It doesn't matter if you have the best sprayer, if you have the clearest part, whatever. If you spray where there's dust floating in the air, all the dust is going to stick to your part and it's not going to look as good. The second thing is don't overspray the parts. So if you guys ever paint a house, you know when you put too much paint in an area, it starts running. Same thing happens with spraying. Depending on the paint you're using, you can actually go back and do a second coat to make sure you don't overspray the parts. But just be aware of that. Don't try dousing the whole thing in paint because it won't look as good. So I mentioned fish eyeing before. Again, this is very much a U.S. term. I'm not entirely certain what the international term is. I've been trying to find out with unsuccess. So what it does is it occurs when the paint surface tension prevents it from really flowing over the part or smoothing out. And so it forms these little craters in your paint job. And this is common well, sorry, it's not common, but it happens with regular thermoplastics as well as 3D printed parts, which is why they make a product called fisheye remover. And what it does is it reduces the surface tension of the clear coat, and so it actually will go through and fill in all those tiny little craters by just making it flow evenly. So if you see this, then you can go add it to your clear coat mixture before you spray it. And again, follow the manufacturer recommendations depending on which brand you're using. So another quick word on surface finish. So we know transparency is directly related to the surface finish of the parts. And so there's different orientations you can use when printing these parts to make them easier to get clear. You can get them clear if they're printed in incorrect orientations. It just takes more work. So the first design and build recommendation we have for MJP, all critical surfaces should be up-facing, and they should be parallel to build plate. So the reason why is sidewalls are more difficult to finish with this type of printer. So you can see with this this part we've been clear coating. We always try building it in the second orientation rather than the first one, just because there'll be a lot less finishing on the sidewalls required. Here's another example that I came across. It was like a little dish that had to be clear. And they tried printing it in 3 different orientations, and the best one was the first one where the majority of the part was parallel to the build plate, and then the walls were as close to parallel as possible. It reduced the finishing time and came out with a good part. They tried these other 2 orientations as well, just took more time to finish. And again, this is only for MJP. Now we're going to talk about micro SLA and SLA. So with SLA, the sidewalls don't require as much finishing. And so you want to orient the parts to reduce the layer lines. Or if you guys are familiar with the technology, if you've heard the phrase stair stepping, you're trying to reduce the stair stepping. And so the orientation on the first one is preferred for these two technologies. A less preferred method would be the second. Again, it's possible to do it if it's the wrong orientation, but it just makes your job easier if you follow these directions. Again, the same part for SLA. The up-facing surface is always the best, especially things that don't have a whole lot of detail. This is the preferred orientation. So one specific example I get a lot of questions on is like bottles or things that need consistent surface finish. So people who don't care necessarily about the top and bottom of the part as much as they can care about the whole part looking uniform. And so we recommend orienting it vertically so that all the cross sections are going to be the same, and it just gives you a more consistent finish, which makes it the end product look better. Another question we get is on accuracy and variability in this process. So it is possible to figure this out, but it really depends on who's doing the process, right? So amount of sanding, it's difficult to get an exact number based on what sandpaper they're using, based on who's doing the process. You know, are they using a machine to help out with the process? There's some variability on this process. And then there's the amount added by clear coat. Typically, it adds about 0.002 to each surface. That's just a good, estimation number. So, for instance, if you take a cube, that's a 1-inch cube. After spraying with clear coat, it becomes a 1 inch and 4 thousandths cube because it adds 2 thousandths to each surface. And since there's two surfaces where you're going to be measuring, it increases it by 4 thousandths. So we actually have a clear coating application guide currently available on 3ds Central. And the nice thing is it contains an overview of the entire process, advantages of our process, some list of equipment, and some troubleshooting. And so it's located on 3ds Central. We're going to send you a link with the webinar recording in email. So this has some more detail, and so it's not as lengthy of a presentation, so it's easier to follow along. And so now I have a summary of, again, back to what we've been talking about. So for speed, the fastest is micro SLA, the largest is SLA, surface quality on SLA and micro SLA are the best, and then the part cross. So just keep this in mind when you're selecting which 3D printer would be right for your application. All right, so now comes the fun part of talking about industries and applications of people who can use this type of process. So the first one is headlights. Headlights are important to be clear, to see how they look, but also to see how they perform in some ways. So this is a really cool application. And so prototyping headlights, we're making them in small quantities for some production. The next one we have is also automotive related, so fluid flow analysis. So this is actually a 3D printed part with an oil reservoir. And so what they were finding is their design, it wasn't allowing the best flow for the most efficient process for their engine. And so what they did is they started printing out their reservoirs and clear coating them so they could actually see what was going on in their process while the engine was actually running. And the next one is also automotive, so engine valve cover. So this was the customer, they wanted to see what was going on in their engine while it was running. And so they actually printed the part out, and again, they did a clear coat. I believe they actually did a specific one for automotive. And they were able to actually turn it on. So they ran the engine while it was going so they could see how it was performing, if there was any issues. I mean, this was quite amazing. You couldn't really have done this with another method because you couldn't justify making a tool for a clear part for this large just for a prototype. So this is another unique, awesome application. So the next one is a group we did with called Parker Hannafin, and so they were making it was an exhaust filter to reclaim some of the unused diesel, and so they started prototyping this with our clear materials. I believe it was done on an SLA machine, either a 6 or 7000 with the SL Clear, and they were able to actually use this for product development, and they were run testing with their this filter. This is another great application. Again, the clarity let them see exactly what was going on during their process. This is an interesting one as well. So this is a clear ear mold. So it's not a hearing aid. It's actually like a headset for like either a news anchor or for a reporter or like a superstar or rock star. They're custom made headphones. So they go in, they scan the ear, and they design it around that and then print it out. So it's exactly meant to fit their ear and match, and then they do the clear coating process to make it smoother, feel more comfortable, and to make it more transparent. So this is another unique, interesting application that can only be done with 3D printing. Awards. So a lot of people like clear wards. They can look nice. Some of the examples we were using is actually an award, and yeah, this is another unique example because you can make customized awards that are not going to be mass produced. And unique for each presentation or whatnot. Display stands are another thing. So because they're large flat surfaces, they're very easy to sand and clear coat, but they're expensive to customize and have someone make. So you can print them out in 3D and then quickly finish them, and they look great and they function the same. So we talked about a little bit more. We talked about this a little bit before. So form fit. So how do parts fit together? Any of these electrical components, like in these examples, does it fit? Where's it rubbing? Where's it touching? Where does it need to be thinner or thicker? And so this is another great process and application for clear coating. Art. We've been finding a lot of artists have been using this, and it's they like it because it kind of frees them up, and then when they do the clear coating process, they can really get a nice glossy, transparent part. And then they've been even experimenting with doing like hollow cavities on the inside so that they can have this like second example. Again, another very unique thing that's difficult or impossible to do without 3D printing. Education is also a huge application that we work with on this. So this is actually a turbine engine that a school needed to print out, and they actually turned it on. So this was a running engine that they had going with the intake, and all the clear parts you can see are 3D printed, and they're clear so you can see actually what's going on, how they're moving, how they're interacting. So the next one is prototyping bottles. Again, prototyping. So our materials are not FDA certified, just a note. So they're only for prototypes. Please don't drink out of them. The next one is cosmetic packaging. So you can see here you can actually prototype different packaging before you go and make the tooling, which is expensive to go to production. So you can see here's a couple examples of where the packaging's very unique and interesting because it's clear. The next one's fashion. So a lot of fashion groups like printing accessories, things that are unique and really only like 1 or 2 offs. You don't need to go to a whole production to make them. So another great application for clear coating. So electronic housings. So I'm sure you guys have seen clear parts for electronics. It's kind of neat. You can see all the pieces behind it. I prototype the housing before you create the tooling. I believe that's all the applications. So now we're going to open up for questions. So I'm going to hand it back to Tom.
Great. Thank you, John Paul. All right. With that, I'm going to start with some of the questions. Regarding VisJet Clear and parts coming off of the ProJet 6000, that's an SLA printer, by the way, all parts turn cloudy after a solvent bath. And he specifies isopropyl or acetone. Without sanding or adding clear coats or other chemicals, how do I get clear parts?
Hi, Richard. Thanks for your question. So what happens when you're building in stereolithography is you get the nice liquid coat on the part. So when it comes out of the machine, it really looks nice and clear. When you go through the cleaning process, the whole point of the cleaning process is to remove any liquid off the surface of the part. So when you are actually cleaning the parts with your washing solvent, like the IPA or the acetone, by removing this liquid coat on the surface, now you're exposing all of the layer line. So then it makes the part look less clear or more cloudy. So there really are, only two options. One option is you don't rinse your part at all. We've had people who just let the part drain for some period of time, and then they put the part in the PCA. So instead of rinsing this liquid coat off the surface, they actually cure it on there, and then the part is very clear. And then, of course, the other option, like you said, and our standard procedure, is to get the accuracy and all the details of the part, is to wash this liquid surface away. And when you wash it away, you expose the surface inconsistency, and then you have to sand it and then clear coat it to make it clear.
All right, thank you, Stacy.
Good, thank you.
For the automotive clear coat, could you also reduce more and wipe on instead of spraying?
Yes, you probably could. The one difficulty is you run the risk of leaving some brush strokes. So if you paint it on it's the same thing with painting a house. If you use a brush, you can start seeing some of the brush strokes, and all these brush strokes will actually ultimately lead to a less transparent part. So yes, you could reduce it more and put it on like that. Some people have done dips and whatnot, but it's just hard to get that nice smooth coat without spraying.
Okay. Another question here is, could we polish the part without using sandpaper due to some geometry limitations such as spiral, internal channel in a tube? So JP, I think you might want to reiterate the hobby knife approach or anything else that's available. Again, some areas are difficult to sand. You can use hobby knife to smooth out. I think the other person was talking about how to get, if you can't sand the part, if you can get clear coat in there. So it's always preferred to sand. You remove the surface variation and then you clear coat and it looks great. If you're doing like internal spirals or whatnot, things that can't be directly sanded, some people have used a sandblaster to try getting in there. Honestly, if you just put some clear coat in there too, it can also improve it. So for example, I had one case where they were building a block and they wanted these spirals to go up through it. And they wanted clear coat actually with the tint to make it stand out and pop. And so what they do is they just pour in a little bit of clear coat with dye and let it run through. And it made it stick out. And then the outside was clear coated in just regular clear. So that's possible, and it has been done as well. Sorry, Tom, I can't find the question. Was that everything they asked? Yeah, I think so. Here's a comment rather than a question. I've found water honing after sanding helps.
Yeah, we've done that as well.
Another question is, are lens quality parts possible, i.e. can I print optical components?
Probably not. Lenses have to have very strict material and process already. And so even if you did smooth out the part and if you clear coat it with a very specific clear coating, it might be possible, but just the amount of clarity required to be considered lens clear, I don't know if it's possible with a 3D printer.
Okay, another question. Can these clear parts be used for medical equipment manufacturing or prototyping, i.e. are they medically safe?
So some of these materials are medically safe. Some of them are Class 6 certified. And there are people who are using these materials as well, particularly the crystal material, which we didn't talk about in a whole lot of detail, that I know for certain is Class 6, and I believe the SLA ones are as well. But yes, this is actually very common to be used for medical applications.
Another question. How about a very fine tumble deburr?
So the risk you run with using a tumbler is you're going to start losing your sharp edges, right? So if you ever put rocks in the tumbler, you notice that all the jagged edges get smoothed out. So depending on the geometry, if you're trying to do spheres or things that don't have a whole lot of sharp edges, then I could see that working well. the one thing is if you're going to put media or like the sand in there to grind it down, make sure you try using a glass bead. If you use a pigmented media, it can get embedded in the part and it can reduce. You can just have a particle in there. So you want to make sure you use something that doesn't have any pigment to it when using any of those type of processes.
Can we polish with rotary polishing tools before adding the clear coat?
Yes, you can. Again, you're not going to get it, to lens quality necessarily. But yeah, we've done that as well, where you take a polishing wheel to it. The one thing to be careful of is it's very easy to break some of these parts. They're not, it's not a metal piece. It's not a solid piece of acrylic too. It's an additive process. So just be careful on fine features that you don't break them off. It's the one thing I have with that. One comment.
Okay, and we have several related questions about using liquid abrasives for sanding inside of the cavities.
Like I guess like kind of like a water honing. So yeah, that can be possible. Again, if it depends on how thick and how large the channels are. If you have a very, very thin piece, just the back pressure from shooting it through, it can damage it if you have very thin features in there. So it can be done, but it really depends on the geometry. So just be careful again not to blast off small features and not to break parts if you're shooting into a small, tiny hole or getting any of the, if there's any media in the liquid blaster, make sure it doesn't get stuck in the part as well.
All right, thank you. There are several questions about whether we're going to share the presentation or not. And yes, just to reiterate, we'll be sending out a recording of the full webinar as well as a link to the applications guide that John Paul referenced earlier on. And everyone who signed up for the webinar will get that email later today or tomorrow at the latest. We have some questions about the Project 3500 and the M3 crystal material. Can you talk about that a little bit, John Paul?
Yeah, so again, we've done the same process. You can get clear parts. In this presentation, we wanted to focus on how to get the maximum clear parts, so the best clear parts out there on the market. The crystal material, it does work. We've done it, and you can get clarity, but it doesn't get to the same level as the SLA, micro SLA, and 5500 material transparency quality, which is why we didn't talk about it as much, because we only want to talk about the maximum level of clarity you can get possible with 3D printers.
And there's a question about the yellowing effect over time on some clear printed parts. Can you speak to that and how to minimize that?
Yeah, so I've noticed that a little bit as well. If you leave parts in the oven for overnight and whatnot, they do tend to yellow a little bit more. So if you're going to be using, and again, the only time they'd be in this is if it's an MJP or a multi-jet process. That's the only one that uses an oven for the standard post-processing. And so if you leave it in overnight or leave it for long periods of time, there is, it does start to yellow a little bit. The main thing is just to take it out when it's done. It only takes a couple hours to melt off all the wax in the oven, so you don't need to leave it in there for 12 or 24 hours. So those are the only times I've noticed that it does that.
And we should also comment that for those of you that have seen parts that were printed a number of years ago, and they may be yellow at this point or have an amber tint to them, a couple of points. One is that a lot of the materials that were being printed several years ago did have that yellowing effect that would happen over time. A lot of that has been engineered out of the process. In fact, if you look at parts from 10 years ago, for example, they would have a yellow or an amber tint almost immediately, whereas today's materials are much, much clearer. So there's been a lot of material science work that has gone on and innovations that have happened over the past few years that make parts clearer right at the beginning and stay clearer over time. Another question is, do speed and layer thickness settings on the printers have any effect on clarity?
So, yeah, yes and no. It will take longer. So if you have a lower resolution mode or lower or thicker layers, it will just take more time to sand and to polish. But you should be able to get it to the same level of transparency, but it will just require more finishing time. So it does affect it. Yeah, go ahead.
I'm sorry. So it really depends on the process. So JP is mainly referring to the MJP process, but for stereolithography and micro SLA, due to the process that is used to create a solid layer of the part, sometimes speed does matter because you can get some more variation through the cure process if you're trying to cure faster. So curing slower and using thinner layers gives us a more consistent even cure, which creates the optical clarity on the inside of the part. And that's what's really important. You know, we talk a lot about why are certain processes clearer than the others. It really has to do with how each technology makes that solid layer. And the more accurate and consistent you can make that layer, the better the optical clarity through the part is. So what we're talking about with these three technologies is those processes, you know, are very good for making the inside very clear. And then so what we're talking about here is only post-processing the outside so that you can see the beautiful clarity through the part, you know, and what the processes we've developed to make the inside clear. So if you try to go faster, it does affect the clarity.
All right, thank you. I think we have time for one, maybe two more questions. Going to one of the earlier questions, I saw many applications in the presentation that involve high heat. Example, engine covers, turbine covers, etc. What is the maximum temperature that the media can be exposed to, and for what length of time?
So it really depends on the material. So each of the materials have different heat resistance. And a lot of times what you can do is you can look at the data sheet, and there's what we call HDT, which is heat deflection temperature. And that is a point where a material can start to what we call sag. A lot of times the HDT of our materials is somewhere between 50 to 65. Just because you reach, or 50 to 65 C, just because you reach that temperature doesn't mean that your part's no longer going to work. For example, if we have an engine housing that's bolted to the engine block, even if it wants to move slightly because it's bolted and sealed to the block, we're going to see that plastic component can withstand 10 to 20 degrees C higher temperatures. So what we always say is look at the HDT of the material, and we know for sure it'll work up to that HDT. And then depending on the application, there's a lot of cases where you get higher heat resistance.
Great. Thank you. Well, that takes us to the end of the hour. So we're going to wrap up at this point. If we didn't get to your questions, we apologize. We will try to answer those via email. After the fact, we had a lot of specific questions about particular printers and material combinations, and so we'll be able to answer those offline. I want to thank everybody for joining us today and spending this time with us. Hopefully you found this session educational and informative, and you're walking away with a bit of new information so that you can print parts that are very, very clear and know exactly how to get the best clarity out of the parts. I want to thank John Paul, Stacy, and the rest of the application development team for their efforts in putting this guide together, both the printed guide and this presentation. And of course, we do recommend that once you get that email, you feel free to share the webinar recording with colleagues, and make sure to download that application guide from 3ds Central, our customer portal. Thanks again, everyone. Have a great day.